Hey everybody, we just had a Zoom meeting and all of the questions were about the gizmo that was assigned on the thermochemistry stuff. So specifically part C. I'm going to go over how to do part C on the gizmo. So it's all about this equation again, and this is what those variables mean. So Q is heat in kilojoules, M is mass in grams, CP is specific heat, which has all of these units, and delta T is a change in temperature. So part C on that gizmo starts off with just a general question. This is the question that's on the worksheet for the gizmo. This was assignment number 7. So we're going to put aluminum into a calorimeter that has water, and the water is going to go up by 2 degrees. So here's what is actually happening. So in the lab, if we were going to do this in the lab, we would have put 2 styrofoam cups together to make a calorimeter and stuck a thermometer in there. But here's what this is saying, is we heated up some aluminum to some temperature. It doesn't say what the temperature is, but it's 125 grams of aluminum, and we drop that into the water, the cool water in the calorimeter, and the heat from the aluminum is going to go out into the water, and we have 1,000 grams of water. That's going to make the temperature go up, it says, by 2 degrees Celsius. So started at 20 degrees, now it's 22 degrees. And so initially what this wants us to do is figure out how much heat energy the water actually gained from that. So this is something you have to do to be able to figure out the specific heat of the aluminum later. So it's asking how much heat do those little red arrows represent? So remember that that's Q. That's asking for Q in this example. So here's all the information that we would need to solve this. This is all based on the original equation. We're solving for Q. And it said we had 1,000 grams of water. We know that the specific heat is 4.18 joules to raise 1 gram by 1 degree Celsius. That was given to you in the worksheet. And the change in temperature was 2 degrees Celsius. So to find out how much heat energy the water gained, we just have to multiply all those together. So it's 1,000 grams times 4.18 joules per gram degrees Celsius times 2 degrees Celsius. Okay, so we're going to multiply 1,000 times 4.18 times 2. So that's 8,360. 8,360, not grams, not degrees Celsius, but joules. Okay, so 8,360 joules. So that is how much heat was released from the aluminum into the water. And the second part of that question wants to know, okay, now that we know that, what is the specific heat of the aluminum? So how much heat can aluminum actually hold? So we're trying to find out Q, which we just did. So we are going to assume that that amount of energy, 8,360 joules, is both how much the aluminum lost and how much the water gained. So for aluminum, we are assuming that the aluminum lost the 8,360 joules to the water. It said, the question says 125 grams of aluminum, and it says that it dropped in temperature by 74.95 degrees. So that's the change in temperature, not the actual temperature. So CP, to solve for that, it's Q over M times delta T. So the Q, that's 8,360 joules. That's energy from the aluminum into the water. The mass of the aluminum is 125 grams, and the change in temperature of the aluminum is 74.95 degrees Celsius. Okay, so 8,360 divided by 125 times 74.95. So that's 0.892. So the CP equals 0.892, and none of those units cancel. So it's 0.892 joules to make 1 gram of aluminum go up by 1 degree Celsius. Okay, so that's how you do all of these problems in part C. This first question just gave you all of the information you needed. So the second question wants to know about copper. And so they don't give you the temperature changes for copper. You have to use the gizmo to find it out. So here is the gizmo all set up. Question number 2 on part C tells you that the copper's temperature is 100 degrees and there's 200 grams of it. The water temperature is 20 degrees and there's 1,000 grams of it. Okay, so you have to set up for the graph. Press play once you get all those variables set. So you see the temperature of the copper drops way down, but the water barely goes up, and that's because water has this huge heat capacity, specific heat. So the water only went up by 1.42 degrees. Very little change, but the copper dropped a ton. So the change in temperature for the water is 1.42 degrees Celsius. The copper went from 100 degrees down to 21.42 degrees. So that's a huge drop. That's 100 minus 21.42. That's 78.58 degrees Celsius. That's how much the copper changed in temperature. That's the delta T. There's the water only changed a little bit. Okay, so how much energy? So if we're thinking about this again, how much energy went from the copper this time into the water? Okay, this is question number 2 on the worksheet, part C. So we're solving for Q. So here's all the information. Why are we using water to solve for energy? That's because we know what water's specific heat is. We don't know what copper's specific heat is. So we have to use water. So we know the delta T is 1.42 degrees. The specific heat is 4.18. That's just a number you have to have memorized. And the mass was 1,000 grams. So I have that worked out. There you go. So it's 5,936 joules or so that went from the copper into the water. Now, just like we did for aluminum, what's the specific heat of copper? So we have to use this value for Q, 5,935.6 joules, because that's how much the water gained, but it's also how much the copper lost. It's the same number. There's 200 grams of copper. We're solving for CP, and we already figured out the delta T was 78.58 degrees Celsius. 78.58 degrees Celsius. Okay, so solve for CP. So CP is Q on top, 5935.6 joules, 200 grams times the delta T, 78.58. That's degrees Celsius. Okay, so we have 5935.6 divided by 200 times 78.58. So there we go. That's our answer. 0.377 or 0.378 if we round it. So CP equals 0.378 joules per gram degrees Celsius. That means that it only takes 0.378 joules to make 1 gram of copper go up 1 degree Celsius. That's a very small number, especially compared to water. Remember, water is over 4. So that's why we see copper go way down in temperature, but water only goes up a little bit in temperature because water's specific heat is so much higher than copper's. The end. So the rest of the questions are just like that, except they want you to do granite and lead.